to touch upon a very interesting topic today around what leads to machine learning models failing, how can we detect them, what can be the potential steps to navigate this, and what are the best practices that we see in the industry today. So, so just a quick agenda so that we are all aligned on the presentation today. So we'll look at the current state of AI machine learning, causes of model failures, ways we can proactively fix these model failures and maintain failure resistance, and a bit about us. So let's walk through what a real life scenario looks like, right? And this is a use case that we've seen occurring again and again across different industries that are focusing on these kind of transactions. So false positives, right, where we are predicting something that is not accurate, but it's getting flat. It's, for example, here what the scenario is that a user attempts to make a purchase. It's an online e-commerce transaction, and they're getting inaccurately flagged but as a fraud user by the model. They are legitimate users, but because they are being flagged as a fraud user, their transactions are going and getting blocked, and the user is unable to complete transaction. Now, what this means is that the organization has lost the business for this user. And oftentimes, this doesn't get identified. And when we look at your traditional software businesses, we see that on a website, we get a 404 error, right? Or we are unable to proceed ahead with what we want to do. On machine learning side of things, those failures are not as evident as a practitioner. I put a machine learning model out there and slowly degrading in quality over time, but that's not evident as a binary yes or no. It's quite hard to detect it. So in this particular case, what you've seen happening is that this may be happening in one particular region. So I'm from Texas, and let's say this user is getting flagged in Texas, but the rest of the world, all the transactions are going through. So then as a business, you wouldn't know this until you were looking at your models granularly for one particular city or state or demographic. And only the way is to get customer feedback, whether that's loss of customer trust, attrition in your customer from a certain region. It takes a few quarters to understand this. So that's an example where we have seen a lot of models misbehaving for a certain segment of the entire machine learning pipeline, and businesses unable to capture the value they were intending. So I will cue this into my first poll question before we jump into broader discussions. But yeah, thanks, Lizzie, to have this up. Maybe we'll leave it up for 45 seconds or so and see, according to all of you, which of these ML at production challenges would add value. Yeah, I think just another 10 more seconds, Lizzie, and we should be good. We're already seeing a clear pattern here in responses. So just a quick outcomes for this thing. So 46% of you say interpreting and explaining black box AI decisions to relevant stakeholders as the most important challenge, followed by sudden drop in models performance for 25% people, and then high technical debt and maintenance costs by model operations, 21% of the people. So wonderful. We'll spend a lot more time looking at the black box AI decisions in this presentation in a later part of it. We can just share the results too. Yeah, so on coming at the first and the second, which were the most important ones, a sudden drop in models performance is what we just looked at, which is hard to identify without the relevant tooling in place, and B, interpreting and explaining black box AI decisions to relevant stakeholders. When we first started, kind of our initial thesis was we were going to provide explainability to data scientists and machine learning engineers. And what we found was more than the actual ML practitioners to understand what is happening, what really helped a business in producing better outcomes were to take these explainability and give it to the end users, whether that meant the leadership, whether that meant external users. And what this allowed them to do without making any changes to their machine learning models was they were able to get better adoption, better traction, better retention of their models, right? Because to the outsider world, it's okay, what is this machine learning model? What's it doing for me? When you tell them, here are the three ways this prediction was made, they feel a lot more confident, a lot more comforted that this machine learning model is predicting something that I believe to be accurate. Uh, okay, wonderful. Let me continue with the presentation. Right. So current state of AI machine learning, and I think these are statistics. Where is popping again? Okay. So these are statistics that we have seen broadly accurate in our own conversations, but this is kind of from IBM. So 68% are not tracking performance variations and model drifts as organizations, followed by not guarding against adversarial threats or potential incursions to keep systems healthy. Because we're talking about anomalies in terms of your data patterns. There's a lot of ways to trick models into giving type of outcome based on what the input is. So you could trick it to have a certain combination of feature values for it to produce an outcome which is not what you would expect it to do. And just last, not monitoring AI across cloud and AI environments. What I'm really interested in showcasing on this slide is that the functional and operational complexities don't scale linearly. They scale exponentially. So the amount of work that needs to be put in when there's one model or two model and there's a couple of people on a team managing it, that starts growing exponentially as the models grow bigger. The reason for that is that the model data pipelines become more complex. There's a greater need to keep everyone up to speed. It's harder to keep track of existing models. It's harder to keep deploying new models. So where we see organizations operationally struggling is that when they move from one or two models to 10, 15, 20, 50, 100 models, they start seeing the pattern of the work piling up, right? And it's either we don't do anything right now, or we use some combination of open source scripts like Grafana or Prometheus to do some level of monitoring, where those tooling wasn't designed to, or they don't have the right frameworks in place to enable them to monitor at scale what they would need to do. So they're either looking to build something more structured internally or adopt a solution that would enable them to do this. Okay, next slide. We'll look at all four of these a bit more in detail in terms of what and why models are failing. So first around the data, garbage in, garbage out, model is being prone to drift, absence of data segmentation and lack of maintenance strategy in model retuning. So let's look at a real use case where this occurred and then jump back into the slide. So Amazon a few years ago built a resume screening system where they were predicting, who should we move to the next level in our evaluation. And what this ended up doing, they ran it for a few months, I believe, and it was discriminating heavily against women. As soon as it saw the name and it predicted was was a man or women, or try to make an analysis there, it would instantly, descore them in terms of the prediction value. And what this ended up being is that they just had an outsized proportion in terms of who was moving to the next round. This happened because there was a sampling error on their end where the model that was trained was not using the right data. The data wasn't balanced for them. It led to those biases getting carried forward at scale without supervision. Sum it up, right? It's if the data that's coming into a model is an inaccurate, it's going to contribute to outcomes in a similar way. So the implications of faulty input data leads to incorrect output, and the more we receive it, the more it costs later to manage and clean it. And it's not just about what data we use for training, but even in the production pipelines, right? Sometimes we'll see data just changing where we weren't expecting those data distributions to occur, which is the next slide for us, where models are prone to drift in three different ways. So a data drift, as in a statistical distribution for your data changes over time. So the best example that we're all familiar with when we went to the 2022 COVID stream, patterns from people changed. They were now, purchasing things differently. They were ordering in more as opposed to going out. Navigational algorithms were affected because people's behavior changes. So those are concept drifts where it's not a technical issue with our models, but the way our models are behaving changes. So it's a concept drift for everyone included. And finally, around upstream data changes. So this is when there are any kind of data pipeline concerns. So let's say measurement systems in miles versus kilometers. So this is one of the software engineers on your team made some change in one of the database systems, which is now suddenly giving away different kinds of inputs to your model. Then these are hard to detect. So model doesn't stay consistent. What we're trying to say here is that your data can change suddenly, just being human errors. It can be drifted over time because consumer behavior changes. So how do we go about and identify this and capture these before they have a significant value on our end business outcome, right? We don't want to wait 1 quarter, 2 quarters and see customer feedback and understand why something occurred in the first place, versus if we can monitor these models early on, then we are able to predict this and proactively understand them. Other thing around data segmentation. So this touches upon a bit of the initial slide I was showing, that it's one thing to look at overall accuracy for a model. So this use case where we are predicting how many users are fraud, and we were having false positives. So in this particular scenario on the right side, we see that this model was 90% accurate, right? Wherever the states of Florida or California and other 50 states, it was performing above 90%. And then for one state, this was not behaving the way we wanted. Now, if the only monitoring that was occurring for a model was for the entire US or the entire world, we would be happy because day in and day out, we would see the accuracy to be consistent with what we were expecting. But on a particular cohort or a subset of your data, they may not be performing ideally, right? It can be a combination of different data segments. So it can be, for example, state plus, it can be their age groups, it can be their income levels. A combination of data segments can have an accuracy that's substantially lower than your overall model accuracy that's being looked at. So it's important to identify and set up more granular level monitoring and make enhancements over time, right? Keep identifying which cohorts for your use case are more important and can have a significant impact. And the way we do it is we look at feature importances for different features for your model in a traditional model, where we look at, okay, here are the 10 most important features for your model. And then we look at different combinations of putting them together, right? Running a model side by side to the actual model to predict which combination of feature and data sets may lead to poor performing cohorts, and then flag them so that we can monitor them, right? So this is a practice that's done in the industry as well, about not always just going in and manually trying to identify these features, but creating a system that can keep surfacing the cohorts that are not performing ideally, and that can just improve the odds of your monitoring significantly. The last thing is about lack of maintenance training and model retraining. I was very glad that not a lot of you pointed this out as a major concern, but it's about now we are creating these frameworks to identify and monitor our machine learning models, but then we need to take an action upon it. Like, models need to be retrained over time. Amazon retrains their model every 7 seconds, for example, because at their scale, that can make a significant outcome in what they're predicting. Most other organizations can vary somewhere from few times a day to few times a month, right? That's a more traditional retraining timeline that we have seen. But being able to create a system that can A, do retraining on a regular basis, and B, either roll back to a previous model when they see an error, or retrain where they see an error, or flag a user and allow them to go and retrain. So being able to have this infrastructure in place that can allow for retraining is equally important to just going out and monitoring the models. So again, uh, in the COVID-induced shift, right? So what it says here is that Instacart model accuracy to predict item availability stock dropped from 93% to 61%. And it took them actually quite a while to fix this, where if there were systems in place that could identify sudden and seasonal pattern shift and correct for it, then models could have been a lot more accurate, right? You would have a lot less unhappy customers at the end of the day, which is the goal behind all of the monitoring and retraining we're doing to improve business outcomes. Three things broader. A, there's reputational impact. So, whether that's healthcare or, that's creating pricing and then changing or stock availability and then not having that, that's an impact to the reputation of an organization. B, there's a financial impact, right? The case we looked at before in online e-commerce when ordering things, if customers are unable to correctly purchase the things they want to do or do the transactions they need to be doing, then that's a financial impact to the organization. And last, there is the legal impact. And this is where explainability and fairness are very important, where for certain industries like insurance, where at least in the US, you're not allowed to make credit decisions on certain protected attributes like gender or socioeconomic status. And what most organizations do is that they just take out, okay, I just take out the feature called gender and I'm good. But that's often not the case because there's still a way for your model to not have that feature in terms of your model inputs, but still, as a proxy, be biased on that feature. So what the ideal practice to do is to take that feature out from the actual model training and the model predictions, but then divide the data on that feature and understand model performance based on it, right? So if you have, different ethnicities listed out or 10 ethnicities, then you want to filter and understand on each of these ethnicities, how is the model predicting, and then compare them, because it's not about not using a sensitive feature in your model, but it's about, is the outcome of the model still accurate or balanced for these ethnicities or sensitive attributes that we're looking at. So that's another area where we do. So Lizzie, let's do another poll around just seeing where are people with their monitoring and maintenance in the production systems, what they look like. Yeah, I think we can end the poll, Lizzie. I think we have our results in. So, well, the results we saw here is that roughly 35% of you went to daily, weekly, or monthly in terms of monitoring the models and the production systems. Another 30% were not doing any model monitoring or maintenance, and the rest were in quarterly, 30%, and then 10% to annually. So just flat off the bat, annually is probably way too little of, or it's way too high in terms of what models to do, unless your models are performing on stagnant data or systematic data. If it's any kind of real life interaction, annually or quarterly is likely not enough in terms of understanding, because models do drift more than that, and more than we expect. And then for the set of people that are not performing any, about 30% are not doing any model monitoring and maintenance, would love to hear kind of in the chats or maybe in the Q&A session, what's stopping them from doing model monitoring, whether that's not needing it or not having the right frameworks in place. So let's look at some ways to proactively spot and fix model failures. So on a broader level, three things, right? Performance analysis, where Is something going wrong? Do we know that? Can we predict it before it actually occurs? Let's do monitoring for it. B, root cause analysis. What is going wrong and explaining it. You've talked to a lot of teams where it's about, oh, we have SHAP and we have Lime and we have some other open source AI libraries that we can explain it, right? So we'll ask them like, hey, are you explaining your model? So like, oh yeah, we have some libraries. But the concern sometimes is not about whether a technology is available, but whether it's available to the right people at the right time and with ease, right? So as a practice, as an organization, what you want to do is to not have your team go and pull all the data out from your database systems and then retroactively spend 2 days writing scripts to explain those model decisions and then make it accessible to the end users. What we want to do is to create a pipeline where they're able to continually explain things, where your explanations are either getting locked in a certain location, or they're able to easily have a framework where they're able to identify, oh, here's a prediction I made. Let me go ahead and explain it. Or look at global explainability. When I mean logging, you don't need to log every single explainability, but we're having global level explainability where in the last 7 days, how was my model working? And then for one data segment, in the last 7 days, how is my model working? Let me compare that with the last 1 month and see if there is a change in how my model is understanding things. Because monitoring statistics are still very objective, where you can have a good accuracy, but it could be consistently wrong, where you want to identify by explaining it if it's understanding the right things. So a good example I like to give is that if you're an algorithm that's identifying whether it's a dog or a cat or an animal, then you want to make sure that on a segmentation model, it's identifying the right feature. It's looking at the body and the fur and the legs to identify it's an animal, a dog, cat, whatever. Not that in the background there is this Christmas tree, right? It's possible that every single of your training data set had a Christmas tree in the background. And then now when you start feeding new images, it continually looks at a tree and oh, it's an animal, right? So it's important to explain and understand if the models are explaining it for the right reasons, and to have a system in place so that the users in an organization are able to get the right information at the right time and finally troubleshoot it. So the best thing, right? If we are doing all this monitoring, we want to go from something went wrong, why did it go wrong, and fix it in a very little time, right? We don't want to be, a machine learning engineer found an issue with my model, and then they're going to, give it to someone else. It's going to look at it later this week, and they'll identify what happened. And the next week, we're going to give it to the data science team to do something with the model. We want to shorten the time frame in a day, right? We find something today, in the afternoon, a user can go and identify why something went wrong and then debug it, and then we have a new model deployed by the end of the day, right? So we want to proactively spot and fix these model failures in a compressed timeline. That's the goal. And that's what organizations do, right? So when you look at large organizations like Uber, Lyft, Microsoft, Amazon, they all build their systems and their infrastructure to do this at a rapid pace. Where other thing is that without a core concept we see with larger teams is that they'll build a platform engineering team within their entire engineering organization, and then have data science team as interfacing teams, like a hub and spoke model, where the teams are not redoing their effort. Because another thing is that we don't want to have every data science team within an organization spend time in infrastructure and building for the same set of things. We would rather have one team work on the infrastructure piece and then have other data science as auxiliary components that are focused on just business activities, because you don't want data scientists to spend time on infrastructure work, but continue to spend time on business oriented activities that would generate value. Uh, Now, I think we touched upon this, but about utilizing, enabling granular level monitoring of data segments. So a few things, right? Monitoring is not just for when we have our ground truths or actuals available. We can still monitor them, right? We can still look at what the input distribution of our models look like, what we call data drift. We quickly touched upon it, but what the input data looks like and what the output data looks like. So let's say the blue over here is your training distribution, right? Where your age groups had two peaks, one, in the 18 to 25 peak and another peak in 55 to 64. Now, in your outcomes, right, in your prediction pipelines, you are seeing that this outcomes are different. Your distributions are different. This means that the kind of data and the distribution of data that your model is receiving is now different. So this is an area which should be flagged. It's not always that this may be a concern, but identifying things like this and flagging that these segments are not what we expected when we first set up monitoring are important. So data scientists can go and look at and understand why this occurred and do this in real time. Um, Around AI explainability. So how can we identify the blind spots and do proactive correction? So there are really good methods now. The open source community has been growing with chat, line, integrated gradient, and so forth. Again, how do we do our explainability for three areas? We do it for local explainability so that on any given prediction, like we see here, we are able to have a prediction and do the explainability for it. B, do explainability for a global cohort so that not just for one individual data point, but for your entire model outcomes, we are able to do explainability and then understand it between different time frames. That's most important, right? Versus last month versus this month or last week versus this week. How is the explainability changing? And the last around being able to do explainability for specific cohorts. I keep coming back to cohorts and data segments because I think this is kind of one of the most underutilized um, or less done parts of any organization when it comes to machine learning monitoring around not putting enough importance to monitoring for specific cohorts. So being also able to do explainability for cohorts, right? Age plus, height plus, city plus, income, and then see how the explainability changes for it. And then finally, understanding the future distribution patterns. Yeah, so I think I talked about is so having periodic retraining on how frequent you should be training. Sometimes some organizations are not always real time; they're batched predictions. So for them, the training intervals could look different. Be performance-based retraining, so we can have something of a challenger versus champion model, where if the model performance drops below a certain threshold, you can trigger a retrain, or you can do a fallback, or you can move to the less complex models, because sometimes complex models work great in the lab, and when we actually use them, they work very differently. So having a fallback mechanism, or last around data changes retraining. So when I'm seeing new data arriving, or we are seeing missing values, for example, and your model is just going wild, and we can move to a model that works better for those outcomes. Lisa, can we do another poll? All right, thank you. All right, I think, Lizzie, that we should have enough responses for this poll. All right, perfect. So sharing the results with everyone, but it was interesting where about, we looked at the previous poll there where there's a significant importance for people that wanted to do explainability and less on other things. And we've seen that I'm happy that, 37% of the organizations or our attendees chose all of the above in terms of what they would like to do, because really it's about doing these things. And if your organization is doing one, that's better than nothing, and then we can do it. So I think the message I wanted to give here is that you should start with what you have and then stack on them, right? Where you don't need to wait to get everything in place as we do models, but start with what's accessible, start with what's available, and stack on these. These things can be added as time goes, but even if it's always like I have one model, I don't need to do anything, that's fine. You don't need to do everything, but we can start with one component, maybe that's just monitoring or just explainability, then keep stacking on the other outcomes that are more important to you as time grows. Where if you need to convince engineers on your team or convince leadership on doing more of the infrastructure management, less technical debt work, then ROI and the performance metrics are fantastic, because if they can see a direct correlation to better business outcomes, they would like to invest more time and resources towards an organization for building out more of these things. All right, so I just have a couple more slides. So yeah, so about us, we've been in our startup for about 2 years now. And again, we talk to a lot of ML practitioners across large Fortune 100 companies to startups to build a platform, a single platform that brings together all of the things we looked at today and more under one roof. It's a cloud native, model agnostic, platform agnostic platform that allows us to monitor the end-to-end ML pipeline, from training to validating to understanding how your deployments are working to monitoring these different metrics, identifying root cause, slicing and dicing our predictions to understand, and then finally collating these insights and creating dashboards to share with your business and leadership teams to understand why machine learning is working or not working, or just have a consistent way to deliver outcomes. So yeah, that's about us. Happy to answer any questions, but I'll do I have one more slide. But how does the tech stack work? And I think not just for us, but just monitoring as a whole, where this is, again, a more complex pipeline with data flow automations and features. So we have some different tools that we've put together here, where we can start from data flow automation, collecting our data, engineering our features, storing them in feature store. Again, another fantastic addition. It's a database that is more catered with machine learning. It's a fancy term, but that's what it is. But about reusing the features so that we don't spend time and energy on recombining the features all the time. Then model training using Jupyter and ML Flow so that we can do A/B testing, model versioning, experiment tracking, serving them in a scalable fashion, and then collecting these monitoring pieces and having a continuous feedback loop that can drive improvements in a consistent way, so that we can close and keep circling to this loop, and then finally having an accessible endpoint for our users. So that's what a traditional, if it's us, if it's internally created system, but this is what a complete tech stack for MLOps would look like.